So first subtract the mean from each value. That's your x minus x bar, and then you square all those. And then you kind of average them. You add them up and you divide by n minus 1. Remember, it's a sample, so it's n minus 1. So after you do that, you're going to end up with 510. Yes? So then your sigma squared, oh sorry, not your sigma squared, your s squared is 510. That's your variance. And your s, if you do the square root of both sides, you get s equals square root of 510. What do you think you guys said was 22.6? Is that right, Michaela? 22? Yeah. Okay, good deal. All right, everybody all good?
Yeah.
Perfect. Okay, lab problem number, this one we're going to skip that one. You guys already do it? Yeah, we're going to skip it, sorry. It's a little bit messier, but you're going to get some messy ones in your homework. So I want you to try, if you tried it, then that's good because it'll prepare you for the homework because the homework's messier like this. If you didn't do it, well, you dodged a bullet today, but you're going to have some messier stuff on your homework. Okay. All right, let's look at some notation. Variance. So S is our sample standard deviation. S squared is our sample variance. Right? They're four samples, so they're regular letters. Our sigma, Greek letter, is our population standard deviation. If you square that, sigma squared is, if you square sigma, you get sigma squared. Square the population standard deviation, you get population variance. I also want you guys to write down the computational model. It's mathematically equivalent to the theoretical one, but it saves time and it's easier when you're doing calculations, especially when. So whenever your mean, let me say this one more time. On your homework, whenever your mean is a decimal, use this one instead. Everybody on board? Otherwise, you're going to get some nasty, messy stuff that will never work out right. You'll spend hours crying over this homework, and you'll be frustrated and want to shoot yourself, or me. Both bad ideas, right? So instead, use the computational model. You will like it. Then you'll be like, oh, that's so much better. Okay? So on your previous page at the bottom where you have sample variance and sample standard deviation, add this formula in. So write down this formula right here in that bottom corner. No. The previous page. So on this page right here, where you have your population variance and standard deviation formula, and you have your sample standard deviation and variance formula, right here at the bottom. Write it in at the bottom, right down here. Bottom corner. Easiest. Right, everybody got the right spot? Not there. Yeah? You guys all on the right page? This part right here? You guys have the right spot? Right here? Right. Yeah. Pick one of those. Rachel, you got that one? All right, good. So let's talk about this a little bit. There's some weird things here, right? N, you guys should be familiar with N. N is your sample size. Everybody good with that part? Yes. This, though, this means that you square x first, then you sum them, then you add them. Right? So. All right, then you sum them up. one here means, with the parentheses, that means that you sum them first. Then you square it. You square that one number. All right, so you'll add them all up, and then you take that number and you square that first. Do you guys want me to put add first, or do you want to put the summation sign first? Add? Or what if I did this? What if I said, does that help? Is that clear?
Yeah.
Okay. So then we'll do one of these in practice next class. And then the sample standard deviation, again, you take the square root of your variance, you get the standard deviation. Okay, I want to touch on this part. Range rule of thumb. How about Drew? Have you read yet?
No.
Great, go ahead.
Range rule of thumb for understanding standard deviation. It is based on the principle that for many data sets, the vast majority, such as 95% of sample values, lies within 2 standard deviations of the mean.
Yes. What does that mean? That means this. Here's my mean. Right? If I go, you guys now know how to calculate the standard deviation. So what was our standard deviation in the last one? It was, the mean was 35. The standard deviation was 22.6. Is that right?
Correct.
If I take 35, I subtract 22.6, I subtract another 22.6, that number, negative whatever, and I take 35 and I add 22.6 and add another 22.6. So that's 35, 70 something. Then 95% of my data is going to lie between those two numbers. The first one we had a mean of 30. We had a mean of 35 and a standard deviation of, what was it? 4.6? 4.5? So the first one, 35, you subtract that, you get 30.5. You take 35, it's 2 standard deviations. So minus 4.5 minus 4.5, so that's 35, 26. You take 35, you add a standard deviation, so 35, 44. 95% of your data is going to lie between 26 and 44. And we only have 6 data points, so they all lie within that. Does that kind of make sense? So that's what it's saying, is if you have your mean, give your mean, and you go, say it was 35, and you go, bump, bump, subtract the standard deviation, subtract another standard deviation, then you take your mean and you add a standard deviation, right? And you add another one. Then whatever these two numbers are here, then 95% of your data should lie between those two values, whatever they are. So these are what we call, oh, sorry, I jumped the gun. That's actually coming up later. But so those are kind of the usual minimum and usual maximum. So for here, our usual minimum is you take your mean and you subtract 2 standard deviations. That's the typical minimum value. Nothing should be below that. Your typical maximum, nothing should be above this, is you take your mean and you add 2 standard deviations. Good. So like I just did a second ago, right? Our mean was 35, and our standard deviation was 4.5. You guys said.
Yeah.
So first, find 2 standard deviations. 2 times 4.5. That's 9. So I'm going to take 35 minus 9, right, so 26. That's my minimum usual value. And then my max usual value would be 35 plus 9, 44. Right, so anything beyond that might be kind of extreme-ish, right? But anything below that might be kind of extreme. Anything bigger than that might be kind of extreme. So who has a little bit trouble remembering PEMDAS and order of operations? I really suggest that you think of this as 2 standard deviations. So find 2 standard deviations first, then add and subtract them. Because what I get is some crazy stuff where I say, what's the minimum and maximum values? And what they do is they take 35, they subtract 2 from 35, and then multiply that by standard deviation and end up with like 140 as their minimum usual value. And there's no way that 140 is anywhere near my usual minimum value. Do you guys understand what I'm saying? Yeah. So, try to find 2 standard deviations first and then check it through. Let me see, there's one more slide. Oh yeah, here's an example. All right, so you guys do this one. This is the last thing we're going to do. So 40 chocolate chip cookies. Okay, so there's 40 chocolate chip cookies. We looked at them to count how many chocolate chips are in there. They have a mean of 24.0, standard deviation of 2.6. Find the usual minimum and maximum values of chocolate chip cookies. Mean is 24.0, standard deviation of 2.6. So this is your example on the page right below that. You make your mean. You're going to subtract 2 standard deviations. First, find out what 2 standard deviations is. How much is 2 standard deviations? Then take your mean, subtract 2 standard deviations. Take your mean and add 2 standard deviations. So I'm going to find 2 STs. That's 2 times 2.6, 5.2. So my min is going to be 24.0 minus 5.2. My max is going to be 24.0 plus 5.2. 18.8, 29.2. Good. Is everybody kind of with me on this part? Yeah. So would 30 chocolate chip cookies be unusual? Yes, it's outside of the range. Is everyone on board? Yes. Okay. Yes.
What goes in here?
The top part. Oh, this is the range rule of thumb. The very top of the page is range rule of thumb. This should be it. This is the thing you're doing. All right. Good. Have a good day. I will see you guys on Tuesday.